many of you were just here to the presentation before by Chef Tess? Any of you here? She was really bubbly. I'm an engineer. We typically don't do bubbly. So I hope we can make this really a general interest presentation. I promise I won't use, at least to the best of my ability, I won't use any engineer speak for those of you that may not do that. So I am curious, though, for those of you that are here, any of you deal with emergency preparedness or disaster prep in your communities or otherwise? So a few of you. Any of you any other types of design professionals, architects, engineers, or anything? Okay. The rest of you is it just general interest that you want to be here? Okay. That actually helps me a little bit. I'll tell you, maybe I'll start a little bit about myself. She introduced me, and I have been practicing as a structural engineer for about 30 years. As a structural engineer in the state of Utah, we know and we prepare for and we design for the possibility and the eventuality that we will have an earthquake at some point. We know that we've had them in the past, and we know from experience of other areas around the world what happens in earthquakes, and so hopefully we do our design so that we can mitigate some of those issues with buildings that are designed and built and constructed per the codes that we have. I personally have had the opportunity to, well, I don't know whether you call it an opportunity, but it really is, as someone that practices in this field, to actually visit earthquake sites and see what happens during an earthquake and what the post-earthquake situation is like. I'm sure everybody here probably remembers the Loma Prieta earthquake in California. A partner of mine and I spent about a week down there, just several days after, visited several of the communities where they were affected by that earthquake, and actually learned a lot. That, at least personally, that the way we pay attention to the design and detailing in our office, it was very beneficial. Northridge, the same thing happened. We actually had a large client that had facilities all over California, and the earthquake happened early in the morning there in Los Angeles or in Northridge, and by about 6:30 in the morning I had a phone call from this client, and they wanted us to get on a plane and come down and look at several of their buildings. It was a grocery store chain, and the reason that they wanted us there is to see if they could open their building. What had happened is, in the general area of the earthquake, because it was so devastating, the building officials just automatically shut down all commercial facilities until they had some way to verify that there weren't any serious damages that were life-threatening. One of the biggest problems right after the earthquake was that the availability of water and other things that are essential for living, and they wanted to be able to sell water, first of all, along with some of the other things. So anyway, we went down, and within several hours, we're right within a mile of where the epicenter of the earthquake was. So that was another opportunity to learn specifically the differences from poor design and construction and adequate design and construction. And interestingly, the building that we went and looked at, that was something that we had worked on and designed, did very well. There was damage inside. There were groceries and all kinds of product all over the floors because the gondolas and the racks tipped over, but the building was fine. So they were actually able to open that store later that day, and they were able to ship in vital products and begin selling them. In 2008, there was an earthquake in Wells. Some of you may have felt that if you were here. It was very slight tremors here, but it did some moderate damage there, and there was actually some buildings where there was severe damage. In 2010, there was the Port-au-Prince Haiti earthquake, and in 2011, the Sendai earthquake. So those are the ones I'm specifically going to talk about today, because I had the opportunity to visit those sites just within days after the earthquakes and spend a couple of weeks specifically looking at buildings. And from an engineering perspective, but also from a human perspective, it was really interesting. And not necessarily as an engineer, but as an individual, I came home, especially after the Haiti earthquake, and we did some things differently at our house to hopefully be prepared for an earthquake. So today we're going to talk about the general observations of the Port-au-Prince, Haiti, and the Sendai, Japan earthquakes, and general lessons learned that may apply to all of us. And then I'll kind of give some thoughts from an engineering perspective. So the Port-au-Prince, Haiti earthquake happened in January of 2010, and then in some ways it seems like that was a long time ago, but it really hasn't been that long. I think what I would like to do is share a few facts about Haiti, because maybe most of you, like me, before I actually went there, I didn't know anything about Haiti other than I knew it was a third world country, and I thought that the only thing I knew about it is I thought that all they did there was practice voodoo and things like that, and it turns out that that wasn't even true. But it has a population of about 10 million people. It's about the size of Maryland in landmass. They have a literacy rate of 53%, and it's the poorest country in the Western Hemisphere. They have an elected parliament, and I say sort of, because they do have a fair amount of corruption in their political process, and they have some real challenges there, which in many ways led to a lot of the disastrous effects of the earthquake. So here's just a view of the city of Port-au-Prince from up on a mountain right along I guess it'd be to the south of the city, and the bay that comes into the country there. It's subtropical, so it's the plant life is lush and green. And there were areas where if you look out at the vistas, you couldn't tell that there had been anything as devastating as a severe earthquake had happened. Interestingly, as I arrived in Haiti, one of the first things that the person that was with us, who was a native Haitian, said is, if you haven't been here before, you need to know the difference between things that are just Haiti, and they have a term for it. They call it "this is Haiti" in Haitian Creole, and things that happen because of the earthquake. And to basically someone from first world country, a developed country, going into a third world country, you probably wouldn't know the difference if there wasn't somebody to point those things out to you. This is one thing that was really common, is on the streets, you can buy and purchase about everything. In fact, most people in Haiti buy and purchase everything on the street, even though they do have stores and commercial operations. And it's not really clear where all these items or products might come from. But it might look like this is a street sale or whatever as part of a recovery effort. That's not true. That's just part of the normal process there. Also, individuals that each day will set up shop along the side of the street and sell their homemade food wares. And typical for most Haitians is every day they get up and do whatever it is they do, and hopefully earn enough money to buy provisions to feed their family for that day. And then they get up the next day and do it all over again, which is kind of foreign for us to think about. This is, again, just a typical shot of a street. The interesting thing here, the reason I took this picture, you see these red and yellow umbrellas. Even as poor as Haiti is, I don't think I met a person that didn't have a cell phone. And their cell phones operate a little differently than us. Most of us have cell phone plans. They pay by the minute, and they could be anywhere and run out of minutes. They'll find somebody that's got one of these umbrellas, and they go them and give them some money, and they punch in their number, and they immediately recharge their phone. And there are literally thousands of those around the city. I found that really fascinating. Those are your neighborhood drugstores, folks that wander around and sell everything from what we had considered prescription drugs to over-the-counter pharmaceuticals. Livestock wandering around, and this is typical in a lot of Latin American countries too, where the goats and the young goats belong to a family, and they go out and forage for the day and come back, and they know where they belong. That is a typical bus, which is a converted truck, and that's probably going about 15, 20 miles from the city, fully packed full of people, and then all of their gear strapped to the top. These are their forms of taxis. They're converted small pickup trucks, and they don't. They wouldn't be like a taxi here. They're more like small buses. They have certain routes that they run, and people will hop on and ride till it's time for them to get off, and they'll bang on the side, and the driver will stop, and they'll get off. So as a structural engineer, one of the things that was interesting to me is how they build things. And unlike a lot of areas in undeveloped countries where they use clay bricks and adobe bricks, if you're familiar with those, they actually have what we typically call here concrete block. And they do a pretty good job of making them. Interestingly, they're not made in big facilities like they are in the States. Quite often along the road, you'll see someone that's got a press like this that's shown on the screen, and some hand mixers or maybe even motorized mixers. And let's back up. And then each day, they'll make 20 or 30 blocks and set them out to cure. And when they're cured, then they'll sell them. And so anybody that's has a construction project, they'll work and find ways to work with these individuals and get enough block. I'll talk a little bit more about how they do some of that in a minute. The other thing is that this would be a metal fabrication facility, and they will take any piece of scrap metal that they can find anywhere and make something out of it. They really are craftsmen with the ability to use things and make things out of things that we would probably just take to the scrapyard. So even for residential construction, this is fairly common. Block walls with some concrete beams and columns. And as you can see, they have reinforcing that gets used sometimes, especially with commercial buildings. And this would be a typical, probably more of a high-end residential construction right here. So the interesting thing in Haiti, there is no concept of a mortgage or a loan for a home. People that have their homes typically build their own home, or they build their own home with the help of friends and family, and they group together and do that. It may take them 10, 15, maybe even 20 years to build their home, because each time they have enough money to buy a few blocks or a piece of rebar, they will do that and build what they can build, and then wait till they have a little bit more money. But then when they're done, they're done. They don't owe anybody anything for what they have. Okay, so some things about the earthquake. Haiti actually experienced a major earthquake in 1770, which is obviously a long time ago in in our human experience, but not really that long ago geologically. Most Haitians at the time that the earthquake happened in 2010 didn't even realize that they were in an area that could have an earthquake. And hopefully we are not that way, that we realize that we have the potential for a significant earthquake here. Apparently at some point there was a decision made in their education process, which is obviously challenged there, that if people thought that they could have an earthquake, it would influence how they did things, and so that it was probably better not to even talk about it. It's kind of the same, in a way, the same approach that for a lot of years happened after the earthquake in San Francisco at the turn of the 20th century. It was known for a long, long time as the Great San Francisco Fire, which it was a fire but caused by the earthquake, and a lot of the damage that did occur was because the fire was out of control and there was no way to put out the fire because they didn't have any water. But there was not really a recognition that places all over can have a fire, so a fire isn't going to be a deterrent from people moving to your city. But if you can have a big earthquake, that might be a cause for alarm. So the 2010 earthquake in Haiti occurred at 4:43 p.m. their time. It was a 7.0 magnitude earthquake, which is similar to an earthquake in magnitude that we could expect here along the Wasatch Front. The epicenter was approximately 10 miles west of Port-au-Prince. Port-au-Prince is the capital city. There were 33 aftershocks greater than 4.0 within 48 hours. And these numbers are there's lots of numbers floating around out there. These are kind of averages from quote official records, but there were 300,000 fatalities, 300,000 plus injured, and over 500,000 that were homeless. And that's, I think, a very low estimate. I don't know, this slide's going to be hard to see, but this just shows the earthquake. And this is Haiti. This is the island where Haiti is. The west half of the island is Haiti. The east half is the Dominican Republic. And if you can see this yellow, that's where the epicenter was, near Port-au-Prince. I think I might have a slide this one might be a little better. But there's where the star is. That's where the epicenter was. But this just shows generally where earthquakes have occurred in the general area. This is what's called the Caribbean Plate. This is all geologic speak here. And where these plates hit each other around the Earth are where earthquakes typically occur. You can see all along here, Central and South America, where the Pacific Plate hits, and then these areas here where there have been earthquakes. And so there is a potential for continued earthquake activity there. Okay, so I'm just going to go through a few slides and show some of the damage. This is some of the earth subsidence. This is a road that is heading west from Port-au-Prince, connecting some of the other smaller cities. And it may not be obvious. You can see the fissure along the side of the road here, but if you can maybe see up here the unevenness of the road, basically this entire road had problems where, because they had the way they had constructed the road, the materials didn't really hold together very well with the shaking, and there was some liquefaction below, which, if you understand what liquefaction is basically the same thing as quicksand, where the soil becomes unstable because it's saturated. And when the shaking of the earth causes the earth to lose its cohesion, and it becomes quicksand. Same type of fissure here. This is a close-up of the area where I was pointing further down the road, where there's lots of subsidence and movement. One of the things that was really interesting, there were very few rock slides in the hills and in the mountains in Haiti, and a lot of it has to do with the way their rock structure occurs. But in a lot of areas where there are earthquakes, that's one of the big problems is rock slides, but that wasn't really a big deal here. So some of the typical damage that happened in Haiti, maybe first of all, a little preface to that. In Haiti, prior to the earthquake, even as big as Port-au-Prince, the capital city was, and there is some major development there, they didn't have a building code. Some more reputable architects, engineers, and contractors would use some design standards. Some of them would even use codes prepared in the United States or in France to design their buildings, but a lot of buildings were designed without any concern or consideration at all for any reasonable design practice. So that's one of the reasons why there was a problem. This is the presidential palace. This is a shot from up on that hill that I showed the earlier slide, zoomed in, so it's not extremely clear. But originally this palace had 3 domes on it on the front side. This is the front here, so we're looking at kind of from the hind quarter of the building. There was 2 side domes and a center dome that was fairly significant, and you can't see it because it collapsed. These are also follow-on pictures, and you can see right here is that center dome that's completely collapsed down to grade level. It's another shot of that close up. This is the block around that presidential palace where all the government buildings were, and you can see the were is the operative term. Most of the buildings on the government complex, they're collapsed. And because of the time of day, they did lose a lot of their operating government people as well as the people that work for the government. So in addition to being challenged in lots of ways, politically they became challenged because then they no longer had a lot of the individuals around that actually held responsible positions. This was a hospital, their term for hospital. Interestingly, in Haiti, as in a lot of countries, a hospital could be anything from a major hospital that we would see here to a small doctor's clinic, and they're all the same, and basically their health care depended on your ability to pay up front for any services you receive. So anyway, this is a hospital. As you can see, as you look at this end of the building is 1 story shorter than the rest of the building because the lower level collapsed on itself. That's looking across to the other side, and this was very typical of a lot of the damage that occurred. This was a university, and you can see there was absolutely nothing left of this university. Interestingly, this university had just opened 3 weeks before, the first week of January. They had moved from a site in the middle of town to a brand new facility and lost almost all of their buildings. So there was some attempt a lot of times, especially with these facilities, to use the right types of materials. They used concrete block, they used concrete, they used reinforcing steel, but how it was utilized, how it was put together and constructed was part of the significant problem. You probably can't see it, but there's a student's desk crushed in the middle of the debris there. This is a cathedral that the entire front of the building collapsed. So I'll just go through these fairly quickly. Here's another picture that you can't really see this, and I took this because it was really interesting. Sometimes it just seems so indiscriminate how the earthquake damaged buildings and areas. There's a building here that's still standing It does have damage. There's a building here that's still standing. Here, this building, which was actually a school, collapsed and fell over and slid into buildings that were fronting the street here. An interesting thing about schools in Haiti, they do have some public schools, but they have literally, in Port-au-Prince, literally thousands of private schools. And most kids go to private school, and it obviously costs more than their public school, but it isn't prohibitively expensive, because that's where most children go, and parents will spend whatever money they do have so their children can go to these private schools, and most of them are not very big. The city of Port-au-Prince sits around the bay with a large, but relatively flat area that is really kind of similar to how Salt Lake and the surrounding area surrounds the Great Salt Lake. And then there are lots of construction up into the hillsides, and where they build into these hillsides, they will use basically every square inch of space. And so, as you can see here, there's a lot of damage, but what would happen because of the way they would build up the hillsides, if they had damage up higher on the hill and things started to slide down the hill, it would just take everything out below it. Again, just another picture of some typical damage. Here's a building which it's not really clear here, but because of the types of construction, they use very little wood. Most of their construction is concrete or concrete block and other similar materials. But there was a fire here, so they didn't have a big problem with the fire that started after the earthquake. They did in some areas, but that wasn't generally a huge concern. And here's just a pretty good picture of looking up a hillside at residential construction as it moves up the hill. You can see to the side here, there wasn't much damage, but down through the middle here, there was a lot of damage where the houses would begin to collapse and just pancake down the hillside onto one another. This is a close-up of that same area, so you can see things are pretty intact here, but here they had total collapses. And this is just looking down a street in downtown Port-au-Prince. Same with this. You can see that there's rubble everywhere. Here's a larger apartment-type building that had some major damage, but it was constructed better than most of the construction there. You can see some cracks between these windows, but this is a building that was actually repairable. Here's one that is not. This was a 3-story building under construction that totally collapsed. One of the things that was really hard hit amongst everything else was school projects, school buildings. And part of the problem with the school buildings, we actually, I'll show some pictures here. We looked at this one specific building that was built in an L shape. And because of the direction of the earthquake, the way the waves hit the facility, one part was heavily damaged, the other part was not. In climates like Haiti, they use natural ventilation. So these were doors into classrooms, but at the tops of the partition walls, they have an open band of windows that makes the building not very stiff in that direction. And then it has a second level that is exactly the same way, which created a real problem for the way the earthquake, you see these columns are severely damaged. And then the area that was the L shape to the area we just looked at, a lot of these side walls just tipped over because of the force of the earthquake, tipped the walls over, but the main structure of the building was not damaged. And this is the same school, so that they had a fairly large open court area for athletic athletics and exercise, and that was a refugee center. And there were these tent refugee locations all over the city. It's interesting that if you go onto Google Earth today, and I think, if I remember right, the most recent picture was from February, and you zoom in, you can still see all these white and blue tents all over the city. So people are still living in these conditions. So just to show the difference in construction and design, this is a school building that was about, I guess, 25 miles from Port-au-Prince, but almost an equal distance from the epicenter as Port-au-Prince in the other direction. But this building had been built by a group from the United States that was trying to improve schools in Haiti. It's about 10 years old or so, but it was designed and constructed more to standards that we would be familiar with. And as you can see, there was very little damage. About the only damage was at locations where they had separation joints between different parts of the building, which though they're supposed to function like that. They're supposed to move and have some damage there to prevent damage to the entire facility. So there is some evidence that the way we design things and the way that we build things makes a big difference on how things behave in an earthquake. One of the other areas that was really severely hit were churches, and I showed a slide earlier. This was the main cathedral in Port-au-Prince, which was kind of the pride and joy of the Haitians in that city and of the Catholic Church. Their diocese headquarters were surrounding this building, and it was over 100 years old, and it was a total loss. There are still some walls standing, as you can see here, but the roof collapsed. And I'll show some slides here in a second. It shows the interior. But it was really interesting that in the city of Port-au-Prince, there were over 80 large Catholic cathedrals and churches. After the earthquake, there were less than 10 of them that were still usable in any way. So it was a pretty significant loss for them, for the ability of the Haitians that are practicing Catholics to attend their services. This is another view of the same building. Here's a view of the interior. This is a building on the complex where that church is located, and this was the Archbishop's headquarters. And originally, this was basically a 3.5-story building. It had a half a level as a basement, and you can see that right now it's a 2.5-level building, and the whole bottom level collapsed, and this came down on top. It was a really a sad story. The earthquake happened, and a lot of the people here survived originally. And right after the first earthquake, there was an aftershock, and the Archbishop had come out on a balcony that's on the other side of this building, and he was trying to get people to calm down. Apparently, there was another aftershock. The building collapsed, and it threw him off of the balcony and killed him. Again, this is a picture of another church. This is from the front. It doesn't look like it sustained significant damage. Then when you see from the side, they had significant damage. This was another building that was a more modern Catholic church, Catholic cathedral. That from the outside, it looked like there wasn't any damage. In fact, they were still using it, and they asked us to come and look at it for them. And we entered the building through a series of tunnels and came up through a basement and walked inside. And I don't think you can see this very well, but it was a really modern looking building. The roof was all concrete, but it had these series of what appears to be cones that were all tied together. Between each one of them, though, they had all come apart. And the only thing that was holding the building up were these single columns at each one of these little cone locations. And here you can see where the building has totally come apart. It was one of those interesting experiences. We have our hard hats on, and we're looking, and we come up the stairs. There was another engineer from Salt Lake that was there with me. We walked up the stairs and turned around and walked back down the stairs, told the other people that we were with that had already gone out, that they needed to come back out of the building with us. Then we quickly went up the stairs and took our cameras above the wall on the stairs and took pictures, and then left. This is a refugee camp that happens to be at an LDS meeting house. A lot of the LDS meeting houses became basically refugee centers. Their buildings fared very, very well, and one of the reasons was because they were designed and built according to plans that had been developed by the LDS Church, and then they had been built according to some codes and design standards. A 7.0 earthquake is a significant earthquake, but there can be bigger ones, and if there hadn't been the degree of poor construction in Haiti, the damage should have been much, much less. Here's just, again, people scavenging sticks and poles and tarps, whatever they can to make some kind of shelter. When the earthquake occurred, it was about 6 weeks before the typical start of their rainy season, and they were really concerned about being able to get people protected before the rainy season happens, which lasts about 2 months, and it just rains constantly for that period of time. This was taken in actually a fairly well-to-do neighborhood, so even they weren't spared. And you can see this vehicle that was crushed under the weight of the entire residence that came down on top of it. Again, these pictures aren't really clear, but you can see this was an area that was set up to distribute clothing and other things, and there's just piles and bales of clothing and people trying to get supplies that they need here. Just a picture of kids, and they can find a way to be happy no matter what happens, it seems like. The other engineer that I was with from Salt Lake, one of the things that the group that we were with asked us to do is to teach a class that had a bunch of young architects and engineers. In fact, they were attending school at that university that totally collapsed. And so we actually were able to spend a day, and one of the things we encourage them in, as part of their careers, is to make sure that in the future Haiti has the necessary design criteria and design guidelines and codes so these kind of things don't happen again. So the Sendai, Japan earthquake happened a little more than a year later, and everybody knows about the damage and the destruction that happened there. Interestingly, it was a magnitude 9 earthquake, so it was significantly larger than, in fact, it was 100. The magnitude of the earthquake, or not the energy, but the level of the shaking was 100 times greater than the Haiti earthquake. So significantly larger earthquake. During that earthquake, Japan moved approximately 8 feet closer to North America. This is according to some geologic information. And the earth actually shifted between 4 and 6 inches on its axis because of that earthquake. The tsunami that was created reached a height of 133 feet and extended inland up to 6 miles in certain areas. And we've all seen the news pictures from that. The energy released by that earthquake was about twice of that as the earthquake that happened in 2004 in the Indian Ocean that created the tsunami there and all the death and destruction. The energy could provide power to Los Angeles for a year if it could be harnessed, and it was 600 times the energy of the Hiroshima atom bomb. I'll move through these really quickly. This is the main island of Japan. This is where Sendai is right here, and there's where the earthquake epicenter was just off. And you can see the color here in the ocean. That's where the Pacific plate hits the Asian plate, and as it goes underneath, that's what creates the earthquakes. I think I'll skip this. This just shows the amplitudes of the tsunami waves in various areas around the country. And this shows the magnitude of shaking in the country of Japan. So here's where it was hardest hit. Tokyo is right down here in this area. So it received significant shaking also. Japan uses some different measurements for measuring their shaking, but it was considered a 7 in Sendai. Now that's not 7 order of magnitude, it's a 7 in their shaking intensity. It was 5 to 6 in Tokyo. And this kind of describes what it is. A 7 is you can be thrown by the shaking, it's impossible to move. 6 is impossible to keep standing without crawling. A 6 minus is difficult to keep standing. So that tells you what that means. This is just a map that shows the amplitudes of the tsunami wave as it left Japan and went across the entire Pacific. So the tsunami was what created most of the damage in Japan. What was really interesting to me, I didn't get up in the Sendai area. I was mostly in the Tokyo area where I was. There wasn't a lot of damage specifically from the earthquake. In fact, things did really, really well there. I can't say there wasn't damage, but there was no life-threatening damage, which is really the goal of any earthquake. But the tsunami that occurred in Sendai was what really caused the damage, and the reality is there isn't much you can do about big waves of water coming at you. So I just have a few pictures. I'm sure everybody saw hundreds of pictures on the news and in magazines afterward. I didn't put this on my slideshow, but I actually have a pretty interesting article that was prepared that shows the difference after 3 months, 6 months, and 9 months in the area that were hit by the tsunami, and how much they had repaired, and the difference between that experience and in Haiti, where there's still very little that's been done, is amazing to me. This was at an LDS meeting house that was looked at. This was the only meeting house that was actually damaged by the tsunami, and he's pointing to the level of the water. But other than the water that went into the building, there was no damage. And this is why. There was this huge industrial facility right next to the building on the downward side of the tsunami that protected it from damage of the waves hitting and then debris hitting the building. So it was safe. So that's one of the things that makes a big difference in a tsunami is it's the pressure of the water, and it's also the debris that's being pushed by that wave that causes the damage. Okay, so this is in the Tokyo area. There was some damage due to liquefaction. A lot of the Tokyo area, much like San Francisco, is built on fill, and fill, unless it's compacted properly, tends to be liquefiable. Right, and that's part of the lessons, and I'll talk about that in a minute. But probably about the same as Japan. Now, that's at least in the areas where we're not going to have a tsunami here. We're not even going to have a tsunami from the Great Salt Lake, although you'll hear people that tell you that won't ever happen. I'll come back to that in just a minute. So liquefaction caused some significant damage in the Tokyo area, and it caused some damage to tall towers, but there was nothing life-threatening and nothing that could not be repaired after the earthquake, just due to the earthquake itself. And I think that's because they had a high degree of preparation, both public and personal. People in Japan expect to have earthquakes, just like in California, people expect to have earthquakes. This is a big comparison here between Haiti, 300 plus dead versus about 16,000 in Japan. 99% of those were because of the tsunami, and not because of earthquake shaking and building collapses. So one of the things that's really interesting is the public knowledge. One of the things that kept showing up on the news was the concern that the Japanese had for the radiation, and they were all wearing these masks. And I don't know how many times I saw that. Have any of you ever lived in Japan or been in Japan? Well, from about November through March, most people wear those masks regularly. That's just what they do. It had nothing to do with protecting themselves. So, but here on our news, we're telling them that that's why they were wearing those masks, is to protect themselves from the radiation. Just quickly, I'm gonna skip this stuff, but I'm gonna show you some damage that happened in wells. A lot of chimneys collapsed in wells, and now that was a 6.0 magnitude earthquake. Another thing that happened was walls and parapets. Parapets are the extension of the wall. It happens above a roof that collapsed. Here's another example of that. So lessons that we can learn, we need to have trusted information sources, and I kind of facetiously say that CNN may not get it right, and they probably won't, which is probably true. So we need to be able to have information from our public agencies and other sources that we can trust. And we need to have a personal understanding of earthquakes. There's lots of information out here. If any of you have been in the Shaker building back here, there's actually a handout they have that talks about preparing or putting down your roots in Utah. It's online. It's a great resource for any individual to know what you can do, even in your own home, to protect yourself. Just in finishing up, one of the things I told you that I changed some things. One of the first things I did when I got home from Haiti was that I bought 2 big rolls of Visqueen and a bunch of duct tape, so that at least I could hopefully patch my house together, and if an earthquake happened in the wintertime, that I could maybe be able to stay warm, which would be a critical thing. In Haiti, they didn't need to worry about staying warm, but we could have that problem here, which could be a serious problem. So I'll just leave it at that. Any questions? Let me just say one more thing. The question about what could happen here, we have a huge inventory of buildings that are between 50 and 100 years old, that are made out of unreinforced masonry. And they are a real source of potential problems in an earthquake. We should be aware of those. And I would just encourage some maybe awareness and maybe some activism. Our state had an ordinance until last year that required buildings that were being re-roofed to be checked to see if those parapets that we saw collapse on the Wells earthquake, and there was many of them in Haiti, are adequately anchored to the roof. It's a fairly inexpensive repair. Well, our legislature took that code ordinance away, but they did sunset it for 2 years. So next year it's going to come up again. I would recommend all of you to be aware of that and encourage your legislators to put that back in our codes. It could save a lot of lives in the event of an earthquake. So with that, I'll just leave it. And if anybody has any questions about my presentation, I'll just hang around at the back afterward.